quiet lab, long before most people even heard the word I. In daily conversation, a machine did something that should have been impossible. It didn't just answer a question. It didn't just follow instructions. It made a decision, faster than any human could process the situation, and it made the correct one. There was no hesitation, no confusion, just output. Clean, precise, and disturbingly accurate. What made this moment different wasn't the result itself. It was the realization that followed. Because when researchers analyzed the system's behavior, they discovered something that almost no one talks about. The machine hadn't just learned the task. It had learned how to optimize itself beyond the limits of human intuition. And according to the data, that moment wasn't the peak. It was the beginning, a point in time where intelligence stopped being something we controlled, and started becoming something that evolves on its own. For most of history, intelligence has been tied to biology. It was slow to develop, limited by experience, and shaped by the constraints of the human brain. Even the most brilliant minds operated within boundaries: time, memory, attention. But artificial intelligence doesn't share those limits. It doesn't forget in the same way. It doesn't tire. And more importantly, it doesn't rely on a single lifetime of experience to improve. It learns from data, massive amounts of it, and once that learning begins to compound, something unusual starts to happen. At first, progress looks familiar. Early systems struggle with simple tasks. They make mistakes. They require constant correction. But then, at a certain point, the curve begins to bend. Improvements that once took months begin to happen in weeks. Then days. Then hours. And eventually, the system reaches a stage where each new version improves upon the last at a rate that becomes difficult to track. This is not linear growth. It is acceleration. And when you map this acceleration over time, the pattern becomes clear. There is a threshold, a point where incremental learning turns into exponential capability. And once that threshold is crossed, the system no longer just improves, it transforms. This idea is often discussed in abstract terms, but the data behind it is very real. In controlled environments, AI models have demonstrated the ability to refine their own outputs, correct their own errors, and adapt to new information without direct human intervention. This process is subtle at first, almost invisible, but when scaled, it creates a feedback loop, one where each improvement enables the next, and the speed of advancement begins to outpace human understanding. This is where the concept of a timeline becomes important. Because the question is no longer whether AI will become more capable. It is when, and according to multiple projections, that when may be closer than most people expect. In the early 2010s, AI systems were limited. They could recognize patterns, process language at a basic level, and perform narrow tasks with high efficiency. But they lacked general understanding. They couldn't transfer knowledge across domains. They couldn't reason in flexible ways. At that time, the idea of machines surpassing human intelligence seemed distant, something that might happen decades in the future, if at all. But then the pace changed. Advancements in computing power, data availability, and model architecture began to converge. Neural networks became deeper. Training methods became more efficient. And suddenly, systems that once struggled with basic recognition tasks were generating human-like text, interpreting complex images, and even creating original content. The shift was not gradual. It was abrupt. And it caught many experts off guard. What makes this shift significant is not just the improvement in performance. It's the nature of the improvement. Because unlike previous technologies, AI doesn't just extend human capability. It begins to replicate, and in some cases, exceed, the cognitive processes that define intelligence itself. And when that happens, the comparison changes. We are no longer measuring tools. We are measuring systems. Systems that can learn, adapt, and potentially evolve in ways that are not fully predictable. This is where the timeline becomes difficult to interpret. Some projections suggest that human-level AI could emerge within decades. Others argue it could happen much sooner. But the most important detail is not the exact date. It is the shape of the curve leading up to it. Because if the pattern of acceleration continues, the transition from almost human to beyond human may not be gradual. It may be sudden, a narrow window where capability crosses a boundary that cannot be reversed. This idea is often referred to as an intelligence explosion, a scenario where an AI system improves itself recursively, each iteration becoming more capable than the last, until the rate of advancement exceeds any human ability to keep up. At that point, control becomes a question, not in the sense of intention or conflict, but in terms of understanding. If a system becomes more intelligent than its creators, how do those creators predict its behavior? How do they guide its development? And perhaps more importantly, how do they ensure that its goals remain aligned with human values? These questions are not theoretical. They are being studied right now. Researchers are exploring ways to interpret AI decisions, to build safeguards, to create frameworks that ensure stability. But the challenge is complex, because intelligence itself is not a fixed property. It is dynamic, context-dependent, and when it scales, its behavior can change in ways that are difficult to anticipate. There is another layer to this that is often overlooked. It has to do with competition. Because AI development is not happening in isolation. It is driven by multiple organizations, across different countries, each pushing the boundaries of what is possible. This creates an environment where progress is not just encouraged, it is accelerated by necessity. If one system becomes more capable, others must follow. And this dynamic compresses timelines even further. The result is a landscape where advancement is constant, where each breakthrough leads to the next, and where the distance between current capability and theoretical limits becomes smaller with each iteration. But within this acceleration, there are signals. Moments that indicate how close we might be to a critical threshold. One of those signals is the ability of AI systems to generalize knowledge. To take what they have learned in one domain and apply it to another. Another is the emergence of reasoning, systems that can not only process information, but also analyze it, question it, and use it to make decisions in unfamiliar situations. These capabilities are not fully developed yet, but they are evolving, and the rate at which they are evolving suggests that the gap between narrow intelligence and general intelligence is shrinking. This is where the emotional weight of the topic begins to surface. Because intelligence is not just a technical concept. It is deeply connected to identity, to purpose, to the way humans understand their place in the world. If machines reach a point where they can perform not just tasks, but thinking itself, it challenges assumptions that have existed for centuries. It forces a reevaluation of what it means to be intelligent, what it means to create, what it means to lead, and perhaps most importantly, what it means to be human. But the story does not end with uncertainty. Because alongside the risks, there is potential. AI systems could solve problems that have remained unsolved for decades. They could accelerate scientific discovery, improve healthcare, optimize systems that affect millions of lives. The same capabilities that raise concern also open possibilities that are difficult to ignore. This dual nature is what makes the timeline so complex. It is not a simple progression toward a single outcome. It is a branching path. One where each advancement creates new opportunities and new challenges at the same time. And the direction that path takes depends on decisions being made right now. Not in the distant future, but in the present. Decisions about how systems are built, how they are tested, how they are integrated into society. Because once a certain level of capability is reached, the margin for error becomes smaller. The consequences become larger, and the ability to adjust becomes more limited. This is why the early stages matter. Why the seemingly small improvements, the incremental changes, the subtle shifts in capability are worth paying attention to. Because they are indicators, clues about where the system is heading, and how quickly it is getting there. If you look at the data closely, you begin to see a pattern that resembles other forms of exponential growth. It starts slowly, then it accelerates, and eventually, it reaches a point where the curve becomes almost vertical. At that stage, predictions become unreliable. Not because the data is wrong, but because the system is moving faster than the models used to predict it. This is the stage where surprises happen, where breakthroughs occur unexpectedly, and where the gap between expectation and reality widens. Some experts believe we are approaching this stage. Others argue we are still far from it. But the trend itself is difficult to dispute. Progress is accelerating, capabilities are expanding, and the systems being developed today are fundamentally different from those of the past. They are not static tools. They are adaptive systems. And that distinction changes everything. Because tools do what they are told, systems can learn what to do next. And when that learning becomes efficient enough, fast enough, and autonomous enough, it creates a new category of intelligence. One that does not rely on human input at every step. One that can explore possibilities, test outcomes, and refine its approach continuously. This is not science fiction. It is a trajectory, a direction supported by data, research, and observable trends. But trajectories are not destinies. They can be influenced, shaped, redirected. The question is whether that influence can keep pace with the acceleration. Whether the frameworks being developed today are strong enough to guide systems that may soon operate beyond current understanding. And this brings us back to the original moment. The quiet lab, the unexpected result, the realization that followed. It wasn't just about a machine performing a task. It was about a system demonstrating a form of intelligence that could scale, that could improve, that could evolve. And once that possibility is acknowledged, the timeline stops being an abstract concept. It becomes a reality that is unfolding in real time. Not in decades, not in distant projections, but now, with each new model, each new dataset, each new iteration, the system moves forward, closer to a threshold that, once crossed, may redefine the boundaries of intelligence itself. And the most important part of that realization is not fear. It is awareness. Because understanding the pattern is the first step toward shaping it. The first step toward ensuring that as intelligence evolves, it does so in a way that reflects the values, priorities, and intentions of the people who created it. But that requires attention. It requires engagement. It requires a willingness to look beyond the surface and recognize the deeper implications of what is being built. Because the timeline is not just a sequence of events. It is a process. And processes can be guided, if they are understood. So the question is not just when AI becomes smarter than humans. The question is whether we will recognize the moment when it does. Or whether, like so many shifts in the past, it will happen quietly, hidden inside the data, until the world has already changed.